Quantum computing could change the world. It could transform medicine, break encryption, and revolutionise communications and artificial intelligence. Companies like IBM, Microsoft, and Google are racing to build reliable quantum computers. China has invested billions. Recently, Google claimed it had achieved quantum supremacy, the first time that a quantum computer has outperformed a traditional one. But what is quantum computing? And how does it work? Let's start with the basics. An ordinary computer chip uses bits. These are like tiny switches that can either be in the off position, represented by a 0, or in the on position, represented by a 1. Every app you use, website you visit, and photograph you take is ultimately represented by millions of these bits in some combination of 1s and 0s. This does great for most things, but it doesn't reflect the way the universe actually works. In nature, things aren't just on or off, they're uncertain. And even our best supercomputers aren't very good at dealing with uncertainty. And that's a problem, because over the last 100 years, physicists have discovered that when you go down to a really small scale, things start to get weird. They've developed a whole new field of science to try and explain why. It's called quantum mechanics. Quantum mechanics is the foundation of physics, which underlies chemistry, which is the foundation of biology. So, for scientists to accurately simulate any of those things, they need a better way of making calculations that can handle uncertainty. And that's where quantum computers come in. Instead of bits, quantum computers use qubits. Rather than just being on or off, qubits can also exist in a state called superposition, where they're both on and off at the same time, or somewhere on a spectrum between the two. Superposition is like a spinning coin, and it's one of the things that makes quantum computers so powerful. A qubit allows for uncertainty. If you ask a normal computer to figure its way out of a maze, it will try every single branch in turn, ruling them all out individually until it finds the right one. A quantum computer can go down every single path of the maze at once. It can hold uncertainty in its head. It's a bit like keeping a finger in the pages of a choose-your-own-adventure book. If your character dies, you can go back to the last decision and make a new one, rather than having to go all the way back to the start of the book. The other thing that qubits can do is called entanglement. Normally, if you flip 2 coins, the result of the first coin toss has no bearing on the result of the second one. They're independent. In entanglement, 2 particles are linked together, even if they're physically separate. If one comes up heads, the other one will also automatically be heads. It sounds like magic, and physicists still don't fully understand how or why it works. But in the realm of quantum computing, it means that you can move information around, even if it contains uncertainty. You can take that spinning coin, and you can use it to perform complex calculations. And if you can string together multiple qubits, you can solve problems that would take our best supercomputers millions of years to solve. Quantum computers aren't just about doing things faster or more efficiently. They'll let us do things that we couldn't even have dreamed of without them. They have the potential to rapidly accelerate the development of artificial intelligence. Google is already using them to improve its software for self-driving cars. They'll also be vital for modelling chemical reactions. Right now, supercomputers can only analyse the most basic molecules, but quantum computers operate using the same quantum properties as the molecules they're trying to simulate. They should have no problem handling even the most complicated reactions. That could mean more efficient products, from better batteries for electric cars, to cheaper drugs, and even better solar panels. Scientists hope that quantum computers could one day help find a cure for Alzheimer's disease. Quantum computers will find a use anywhere where there's a complicated system that needs to be simulated. That could be anything from predicting the financial markets, to improving weather forecasting, to modelling the behaviour of individual electrons, using quantum computers to improve our understanding of quantum physics. Cryptography will be another key application. Right now, a lot of encryption relies on the difficulty of breaking down large numbers into prime numbers. This is called factoring, and for classical computers, it's slow, expensive, and impractical. But quantum computers could do it easily, and that could put our data at risk. There are rumours that intelligence agencies around the world are already stockpiling vast amounts of encrypted data in the hope that they'll soon have a quantum computer that can crack it. The only way to fight back is with quantum encryption. This relies on the uncertainty principle, the idea that you can't measure something in the quantum realm without influencing the result. Quantum encryption keys could not be copied or hacked. They would be completely unbreakable. You'll probably never have a quantum chip in your laptop or smartphone. There isn't going to be an iPhone Q. Quantum computers have been talked about for decades, but the reason it's taken so long for them to arrive is that they're incredibly sensitive to interference. Almost anything can knock a qubit out of the delicate state of superposition. As a result, quantum computers have to be kept isolated from all forms of electrical interference and chilled down to close to absolute zero. That's colder than outer space. They'll mostly be used by academics and large businesses. who will probably access them remotely. It's already possible for anyone to access IBM's quantum computer via its website. You can even play a card game with it. Right now, the best quantum computers have about 50 qubits. That's enough to make them incredibly powerful, because every qubit you add means an exponential increase in processing capacity. But they also have really high error rates because of those problems with interference. They're powerful, but not reliable. And that means that for now, claims of quantum supremacy have to be taken with a pinch of salt. In October 2019, Google published a paper claiming it had achieved quantum supremacy, the point at which a quantum computer outperforms the traditional one. But its rivals disputed the claim. IBM said that Google had not tapped into the full power of modern supercomputers. Most of the big breakthroughs so far have been in controlled settings, or using problems that we already know the answer to. And in any case, reaching quantum supremacy doesn't mean that quantum computers are ready to do anything useful yet. Researchers have made great progress in developing the algorithms that quantum computers will use, but the devices themselves still need a lot more work. Quantum computing could change the world, but right now, its future remains uncertain.